Software architecture is not about drawing complex diagrams. It is about making technical decisions that survive business growth, increasing users, system complexity, and unexpected failures. Good software architecture is not about choosing the latest technology or creating the most complex system. It is about finding the right balance between multiple important factors. Business goals. First, architecture must support business objectives. A solution should help the organization deliver value faster, improve customer experience, and support future business growth. Technical constraints. Every project has limitations: existing systems, technology choices, team skills, budget, and deadlines. Good architecture works within these constraints while creating the best possible solution. Maintainability. A system is not built only for today. It must be easy to understand, modify, test, and enhance as requirements change over time. Security. Security must be part of the architecture from the beginning. Protecting data, controlling access, and reducing risks are essential for reliable systems. Scalability. As users, transactions, and business demands increase, the architecture should be able to grow without requiring a complete redesign. Cost. Finally, architecture must be financially practical. The goal is not to build the most expensive system, but to build the right system that delivers value. Microservices are powerful, but they introduce operational complexity. A modular monolith is often the better starting point for many products. Another important architectural decision is choosing between synchronous and asynchronous communication. REST APIs are commonly used when a user or system needs an immediate response. For complex systems, asynchronous communication using messaging platforms like Kafka or RabbitMQ can provide better resilience. Instead of one service directly calling another service, it sends a message to a queue or event stream. One of the most common architectural decisions is choosing the right database technology. Many teams ask, which database is faster, SQL or NoSQL? But the real question is not about popularity or performance benchmarks. The right choice depends on the business problem you are solving. SQL databases are designed for structured data, strong relationships, and reliable transactions. NoSQL databases are useful when applications need flexible data models, high scalability, or large volumes of rapidly changing data. Many organizations focus only on building the fastest system possible, but a highly optimized system can become expensive and difficult to maintain. Architecture is not about maximizing performance at any cost. It is about finding the right balance between user experience, reliability, scalability, and business value. Performance means ensuring the system responds quickly and handles the expected workload. This may involve optimized database queries, caching frequently used data, load balancing traffic, efficient application design, scalable cloud infrastructure. But performance improvements come with a cost. Running more servers, larger databases, and additional infrastructure can increase operational expenses. A good architecture considers questions like: do we need real-time processing everywhere? Can we use caching instead of expensive scaling? Can some workloads run asynchronously? Are we paying for resources that are not being used? Great solution architects do not just select technologies. They understand business objectives, risks, constraints, and future growth to create practical solutions.